Dear students, welcome to another lecture in critical path method. Yesterday we have seen how to draw a network diagram from the given information. Now today let us see how to draw the critical path, how to identify the critical path of a network. Now here this table is given. Now the activities are given. Now A to B is one activity, A to C is another activity, A to D is the third activity, like that. So many activities are given and their duration is given. Now if you draw the network diagram, it will look like this. You see, now this is A to B. Now A to B, it is taking 8 units of time. This units can be anything. It can be days, it can be hours, it can be minutes, depending upon what type of project it is. Okay, A to B is 8, let us say it is minutes, so 8 minutes. A to C is 10 minutes, A to D is 12 minutes. Then we have B to C, 8 minutes. You see, with the help of this diagram, you'll be able to draw this network diagram. With the help of this table, you'll be able to draw this network diagram. It is not so difficult. Okay, you may have to draw first a rough sketch, and then you can draw a fair sketch later, because you will not know exactly where the positions of these nodes will be. By node I am meaning these dots, these circles. These circles we are calling events, and these arrows we are calling as activities. Okay, yesterday we have seen that these nodes or these events, they don't take time, whereas the activities take time. Now this 8 hours or 8 minutes time that is given, 8 units of time that is given, is for the activity. Okay, now here A is an event, B is an event, and A to B is an activity, like that, because it is starting at A and it is ending at B, so this is an activity, like that. Okay, now all these things, B to C is 8, then D to E is 12, D to E is 12. Now you should know where to put E, because you can place here initially. See, that's why you may have to do a rough sketch, because in the first time itself you will not exactly know where the position of each event will be, how the activities will be. Okay, now D to E you have taken, then D to F. Now D to F is this one, which is taking 14 minutes of time, and C to E is taking 12. Now this is C, this is E. This should have been given before, because after drawing E and F, then we are drawing this activity of 12 units time. Okay, anyway, E and F, E to F, now this is E to F, and that is taking 9 units of time, and B to F, finally, this is taking 16 units of time. Now the question is, you identify the critical path. Now what are you having? You are having the nodes, that means those events, and you are having the durations of the activities. Okay, now let us see how we can do it. Now you come to the next slide. You see, the same thing here, it is drawn with each node given further information of EST and LFT. EST is an earliest start time, and LFT is latest finish time. See, these two things, this information is provided at every node. At A we have provided, at B you have provided, at C you have provided, see, on the top and on the bottom, at D you have provided here and here, at E you have provided up and down like this, and at F also you have provided. See now how many totally? There are 6 nodes, and at 6 nodes we have provided this information of EST and LFT, early start time and latest finish time. Okay, now some values are also given. Now these values we have to compute, we have to calculate. Now I'll tell you how to calculate these values. Okay, you see now our starting node is A, that is the starting node, and our terminal node is F, that is the finishing node. Okay, so always the starting node will take an early start time of 0. It should start with 0. Now first let us calculate all the ESTs of all the nodes. Now EST of A is 0 because this is a starting point. So at starting point we start with 0. This will be 0. Okay, now what is the duration of this activity AB? That is 8. Okay, now at the node B we want to find out EST. Now what you have to do is, in this activity at the starting point what early starting time is there, to that you add the activity's duration, that means 0 plus 8, and that gives you this value 8 at the node B. Okay, now come to node C. When we come to node C, you see node C is getting inputs from two sides. You see one arrow is coming from B, another arrow is coming from A. Now you have choice. Okay, now here if you take BC, what happens is the earliest starting time of the starting node is 8 and the duration is 8, so it comes to 16. That is what is written here. But if you take AC, what happens is, if you take this, the earliest start time is 0 and the duration is 10, so 0 plus 10 is 10. Now when you are having such an option of, you have to choose between these two values. Now through 2 branches you are getting information, data. Now the earliest start time we will take the maximum of these two values. Through this route we have got 16, through this route we have got 10, so which is the greater value? 16 is the greater value, so the EST of node C will be 16. Now let us come to the node D. At the node D, now we have to decide what is the early start time. Now early start time, here this node is getting input only from one source, one way, one arrow. So then what you have to do is, early start time here, what is the formula? See, the early start time of the starting point of this activity, that is 0, and the duration of the activity, that is 12. 0 plus 12 is 12. So that is what we have written here. Now we have found out what is the EST of the node D. Now come to E. Now when we come to E, again we see that this E is getting, we can reach E through two branches. One is this route from C to E, another is this route from D to E. So now you will get to 2 values. So which value to take? Yeah, you are right, whichever is the maximum value. You see, when we are going from initial point to the terminal point, you see, you should always take the maximum values. Now let us see first this D to E. Now we have to find out the EST. Now from D to E, D's early start time is 12. Okay, here Now D's early start time is 12 and its duration is 12. Now 12 plus 12, this gives you 24. So through this route we are getting 24 EST for E. Whereas through this route, if you come, here the earliest start time for C is 16 and this duration is 12. 16 plus 12 is 28. Now which will you take? Will you take 24 or 28? Whichever is the maximum value you have to take. So you will take 28. Okay, now you come after E, you come to the final terminal point, terminal node, that is F. Now here you have to decide what is EST. Now if you see this node F, this is getting we are reaching this point through 3 branches. You could have come from B to F, you could have come from E to F, or you could have come from D to F. Now 3 EST values you will have. Now for EST value here F, let us see through this route BF. Now B's EST is 8 and its duration of the activity is 16. So 8 plus 16 is 24. That is one value you are having. And through this route D to F, here the EST is 12 and this duration is 14. So here EST what we are arriving is 26. Through this route we got 24, through this route we got 26. But if you are coming through this route E to F, see the EST of event E is 28 and the duration of the activity is 9. 28 plus 9 is 37. So the 37 is the maximum of the 3 values. So what you decide is you take the maximum value, that is 37. So this 37 is the EST of the terminal point. So this is the project duration 37. But what you have to do is you have to calculate these values also, LFTs. Now we have calculated only ESTs. You understood now how to calculate ESTs. So you start the node, initial node you should take 0 and you take the activities duration, add these two things and you will get the EST of the next node. But if it is having, if you are able to reach that node through 2 branches, you have to calculate ESTs for both the branches and whichever is the larger value that you are going to take. Okay, like that you have come. And finally you have seen at the terminal node that you are reaching here through 3 branches, and for all the 3 branches you have calculated the EST and whichever is the maximum you have taken, and that is 37. Okay, now let us see LFT. As you start, you took EST of the starting point as 0. Now here for LFTs you go from terminal point to the starting point, and LFT value you will take the same as the EST of the terminal point. That means you start LFT of F with 37. So 37 you take. Now 37. Now next from 37, okay, after F you come to the node E. Now you are going in the backward direction. So now 37. Now how are you reaching this LFT? This LFT you are reaching with the LFT of the final node minus the duration of the activity will give you the LFT of this node. Okay, see, the LFT of the starting node of an activity is the LFT of the end node minus the activity duration, which is 9. So 37 minus 9, that gives you 28. So you have written 28. Okay, now you have written LFT of F also, you have written LFT of E also. Now after F and E, let us come to D. Now D, you are able to reach, you know, D. When you are coming D, see there are two branches here for D. So you have to see through both the ways. You see here it is 28 and the minus of the duration, 28 minus 12. 28 minus 12 will give you 16. Okay, and 37 minus 14 through this route, 37 is the LFT, duration is 14. 37 minus 14 will give you 23. Now one way you are getting 16, another way you are getting 23. Now which value to take? See, when you are finding out the LFT values, that means when you are coming from the terminal point to the starting point, or in the backward direction, in the backward way if you are taking, then you have to take the minimum of the two values. Now instead of 23, you will take 16, because 16 is the lower of these two values between 23 and 16. Okay, so now LFT of the node D is 16. Okay, now come to C. Now C outgoing is only 1, so it is easy. 28 minus 12 is 16. That LFT 16 we have written here. But if we come to B, now B outgoing 2 are there, 2 arrows are there, so both ways you have to calculate. One way is 37 minus 16, this is 21, and this way if you come, 16 minus 8 is 8. Now which is the which is the least of these two values? 8 is the least. That's why 8 we have written here. Now finally when we come to the node A, you outgoing 3 branches are there, 3 arrows are there. So in the 3 you have to see. You see, let us see first this AD. So here 16 minus 12 is 4. And through this branch, this 16 minus 10 is 6. And here 8 minus 8 is 0. Now which value you will take? You will take the least value, that is 0. Okay, anyway, because it is the starting point, LFT will be always equal to EST. Now these two values and these two values of the terminal points will be same. Okay, so like this you have to calculate the EST values and LFT values. That means early start times of every event and latest finish time of every event. Okay, now what was the question for us? The question for us was, we have to identify the critical path. Now the critical path, how to identify? You see, the critical path is that path where these two are equal. You see, that means the float is 0. You can say float is 0 means this minus this, the LFT minus EST is 0. You see, 0 minus 0 is 0, 8 minus 8 is 0, and 37 minus 37 also is 0. So then will the critical path be like this, A, B, F? No, but whichever is the longer route. Okay, here you see 16 minus 12 is 4. So here there is a difference, it is not 0. That means this node D is not in the critical thing. Whereas if you come to node C, this is 16, this is also 16. 16 minus 16 is 0. So this will be in the critical event. Okay, in the critical path, this node will be in the critical path. And if you come to E, this 28 and this is also 28. 28 minus 28 is 0. And if you come to F, this is 37 minus 37 also is 0. Now only node that is not there in the critical path is D. Now you have to draw a critical path connecting all these things, going through all these things. Now how that critical path will go? You see, from A to B, B to C, C to E, and E to F. This will be the critical path. Okay, A, B, C, E, F. A, B, C, So A, B, C, E, F, this is the critical path. Okay, now you can see, if you observe carefully, actually these arrows are little darker. Can you see? This is dark, this is darker. Compared to this and this is this dark, this is dark, this is dark, and this is dark. See, the through dark lines of arrows we show the critical path, and otherwise you could have shown it with double lines also. Double lines, that means two lines you can show this arrow, this also two lines, this two lines, this two lines, like that critical path you can show. Now we have found out what is the critical path. Critical path is that path which has the activities which cannot be delayed. Suppose this activity is taking 8 minutes, but if instead of 8 minutes you have taken 9 minutes, suppose, that means 1 minute you have taken more. That means what? In that case, this project will not be completed in 37 minutes. It will extend by that 1 minute, supposing that all the other things you have done on time. Okay, so you cannot delay this. You cannot delay the critical activities. If any critical activity is delayed, the project duration is going to increase. Okay, that is how it is. Okay, now let us go further. Now let us see here. Now the same network. Now the activities are AB, AC, AD, BC, DE, DF, CE, EF, and BF, and these durations are given here, and these are only column numbers. This is first column, this is second column, which has duration. First column is activity, second column is duration, third column is the earliest start time, EST, and fourth column, fourth is not here, this is fifth, this is sixth, this is fourth. This fourth column is latest finish time. You see, earliest start time and latest finish time directly we can get, whereas latest start time and earliest finish time, for these two you have to calculate through formulae, and those formulae are given here. Latest start time and earliest finish time. Latest start time will be latest finish time minus duration. Duration means, here it is given as Tij. Tij, I is the starting node and j is the ending node. If it is node is A and another node is B, between these two the activity is there, then it will be TAB, like that. If it is 1 and 2, it will be T12, like that it will be. Okay, so T is the duration of the activity. So you see, LST is LFT, that is latest finish time, minus duration, that is Tij. This gives you the latest start time of that activity. Okay, and then earliest finish time. For earliest finish time, see here, earliest finish time, the formula here is earliest start time plus duration. That means EST plus Tij. That's what is given here. Earliest finish time is EST plus Tij. Okay. Now, so now we are having this is the first column, second column, third column, this is the fourth column, this is the fifth column, this is the sixth column, and the seventh column is a float. Now float is calculated in two different ways. Float can be LFT minus EFT or LST minus EST. See, latest finish time minus earliest finish time is float, or latest start time minus earliest start time also is float. Both of them, any of the formula you can use, both, because both will work out the same. Okay, same values you will get. Now let us see, let us calculate all these things, or let us find out all these timings, and let us also find out the float for every activity of this network diagram. Okay, now let us take the first activity, AB. Its duration is 8. So the earliest start time, you see, earliest start time is 0. You see, like like this is the activity, and this is the earliest start time 0, and uh, latest finish time is 8. Earliest start time, latest finish time of this activity. Earliest start time is in the column 3 and latest finish time is column 4. This 0 and 8 for that activity AB we can write. Then afterwards, now latest start time. That means if you are delaying, how much you can delay so that the project duration will not be prolonged, extended. Okay, so for that now latest finish time, that is in the column 4 minus the column 2. Column 2 is the duration. Okay, LFT minus DIJ, that is 8 minus 8 is 0. Okay, that means there is no latest start time for it. This is also 0 only. Okay, whether you don't have any gap, any time lapse here, whether it is earliest start time or latest start time, you have to start at 0 minutes. Okay, like that. Now earliest finish time is earliest start time plus the duration. Earliest start time is there in the third column and the duration is in the second column. So these two you add. This is third column, 0 plus 8. Actually it is put in the reverse direction. Okay, 0 plus 8 is 8. Okay, so and finally we are calculating the float. For float, either you use LFT minus EFT, that means this minus this or this minus this. Okay, this minus this, that is 8 minus 8 is 0. So here the float or the slack of this activity AB is 0. Now similarly, if you come to AC, you see its earliest start time is 0. You see, for all these things, for AB also it is 0, AC also it is 0, and AD also is 0. For all the three it is 0. See, that's why these are 0. But durations are different. Okay. Now, latest finish times, if you see, latest finish time for this activity is 8. For this activity is 16. For this activity is 16. Okay. So that's what we have written here, 8, 16, 16. Now we have to calculate this. This is this is, now we have to calculate for AC. You have to calculate the latest start time. Latest start time is latest finish time, that is the 16 minus duration. The 16 minus 10, that means 4 minus 2. 4 minus 2 is 6. Okay, and earliest finish time is 2, second column and third column. Second, third, and second and third, if you add 10 plus 0 is 10. Okay, like that. And the float is just these two columns. Now if you subtract 16 minus 10 is 6. So this is the float. Okay, similarly for AD, you take the duration is 12, earliest start time is 0, and latest finish time is 16. Now 16 minus 12 is 4, and 12 plus 0 is 12. Okay, now if you subtract 16 subtract 12 from 16, you will get 4 here. This is the float. Okay, like that. Now when you come to BC, now now BC, let us see in the diagram. BC is this earliest start time is 8 and latest finish time is 16. Okay, for this activity we are not saying for node. When you are saying BC, it is the activity BC. Okay, earliest start time and latest finish time, 8 and 12, these two values are there here. You see, this is 8 and what, 8 and 16, sorry, 8 and 16. Latest finish time is 16 for C. Okay, so 8 and 16 you first write here, 8 and 16. Next what you do, Next, what you do is you have to calculate the LST. LST is 16 minus the duration is 8, and you have to calculate EFT. EFT is these two columns you have to add, 8 plus 8, 16. Okay, so now the float is these two. Subtraction of these two, 16 minus 16 is 0. Okay, like that for all the other activities also you calculate. Okay, now DE. Now let us see whether you get 12 and 28 values for DE. Okay, now let us see for DE. DE is here. Okay, early start time is 12 and latest finish time is 28. Did you get that? 12 and 28? Yes. So 28 minus 12 will be 16 here, and 12 plus 12 is 24 here, and 28 minus 24 is 4. Okay, like this you calculate for all the activities. So once you calculate all the activities, now what you can do is the activities with zero float are in the critical path. Now which activities are in the zero are having zero float? AB is having, then BC is having, then CE is having, EF is having. So A, B, C, E, F. A, B, C, E, F. A, B, C, E, F. You see, this way also you can find out the critical path. Okay, in two ways we have seen how you can find out the critical path. Critical path can be found out from the network diagram itself. You see, this is the largest path connecting all the critical events is the critical path. Otherwise, all the zero float activities constitute the critical path. So in either way you can calculate this thing. You can find out the critical path. Now let us quickly see another problem. I'll not be going through all the details, but some of the important things we'll see. This is the initial sketch that you draw. You see here you see a dummy activity. Dummy activity 7 to 6 is a dummy activity. Okay, because this I may be depending upon E, F and H. That's why it is we had to draw like this, a dummy activity. We have already seen dummy activity. It doesn't require any time, and it doesn't consume any resources. Okay, so as per the network rules, you see every network should start with one node or one event and end with one node. See, there should not be branches. You see, two branches are still standing at the end. It should not be like that. Everything should start with one node and end with one node, and this is the network. Once the network is drawn initially, then you make a fair copy of it see, as it is given here, and then its activity durations you can write just below the activity number. Now A is the activity, and it is taking 10 units. And now B, C, D also, see, below B you write its time, below C you write its time, below D you write its time, and E, F, G also you can see, below E, below F, below G also you have written. And dummy doesn't take any time, so it is 0. Okay, but H, no, it is its thing you can write here. If you cannot write just below, you can just write beside it also. And for I and J also, for I7, J18 also, all these are the durations of the activities. First you write those things. Now afterwards what you have to find out is, you have to find out EST and LFT. Now initially you start with the ESTs and go towards the terminal event. Okay, so here start with 0, 0 plus is 10, you come up to 10 here, and here if you come, see 10 plus 5 is 15, and 15 plus 6, oh, there is another root here, so wait, so let us come to here. It is only one incoming arrow, so no problem. 10 plus 3 is 13. Here also one incoming arrow, so no problem. So 10 plus 2 is 12. See, all these things are done. Now come here. Now you can come here because it has only one arrow. See, here 12 plus 5 is 17. You have written here. And if you are coming here, there are two branches. You see, either it can be 13 plus 15, 28, or it can be 17 plus 2, 19. Which will you take? Larger of the two values you take. So 28 you are taking. Now if you come here, there are two branches here. Though dummy is there, but still the dependency is there. So you have to consider that also. So if you come here, this is 28 plus 0, 28, and this is 16 plus 15 plus 6 is 21. So 21 and 28, which is more? 28 is more. So you write here. Okay, and finally when you come to the terminal event, so here you see you can take 28 plus 7 or 28 plus 18. Okay, which one will you take? You have to take 46, whichever is the larger value. Now go for finding out LFT, go in the reverse direction. Start with the same value of LFT as that of EST for the terminal node. That means for node 9 you take LFT is equal to the same value like this, 46. Now 46, and from here if you come here, now outgoing only one arrow, so no problem. 46 minus 18 is 28, so 28 you have taken here. And if you come here, there are two branches here. See, this is 28 minus 0 is 28, otherwise 46 minus 7 is 39. So whichever is the lower value, when we are coming back, no lower value you should take, that's 28. Okay, now if you come here only one outgoing arrow, so 28 minus 2 is 26, you wrote here. And if you come here, only one outgoing arrow, so 26 minus 5 is 21, you have written here. Here is only one arrow, this is 28 minus 15 is 13. Here also one arrow, so this 28 minus 39 minus 6 is 33. Okay, now here if you come, there are three outgoing arrows. Now you have to take the least of all the three. You see, if you say 33 minus 5 is 28, and here 13 minus 3 is 10, and 21 minus 2 is 19. Which is the least? 10 is the least, so you have taken 10. Now 10 minus 10 is 0. Okay, like that you can calculate all these values. Now you have to find out the critical path. The critical path, first node and last node will always be there in the critical path. So you have to start here. So there is only one route, you come here, but here there are three branches. Now you have to choose which branch you will go. Okay, and here now there is a difference between these two timings. There is a difference between these two timings, so these two cannot be in the critical path. So this is the critical path because these two values are same. 13 minus 13 is 0. The float is 0 here, and here 28 minus 28 also is 0. Here also 28 minus no, this is 39 minus 28. Okay, this is, so now the critical path is this 1, 2, 4, 7 and 9, because all the others are having float. Okay, this is the critical path. You can darken it, you can make it double line, and you can do it. Okay, then you can next what you can see is you can calculate the ESTs, LST, EFT, LFT, and float also. Float, total float, free float, independent float also you can find out. So these are the values, free float formula and independent float formula, and finally you can write this is the critical path 1, 2, 4, 7, 9. Is it that one? Yeah, 1, 2, 4, 7, 9 is the critical path. This is how you solve the network problems or the critical path method. Okay, so So dear friends, with this we have finished we have briefly seen the critical path method also, and and now the chapter 2, we come to the end of the chapter 2. Okay, so in the next lecture we will start chapter number 3. We'll stop here for today. Thank you.